Hello, and welcome to another session of just messing around with code. So, like everyone else, I started with C in college and university, and I've had some jobs in C++, Objective-C, whatever. And then I somehow ended up in JavaScript, which is generating more money for me on my main job, which is fine. But since I'm trying to learn Rust more and more intimately, I want to see what kind of benefits I get. Of course, one of them is always on the internet. It's mentioned that there's a lot of speed in there because it's compiled language and it doesn't have any garbage collector. Well, that's all fine. But as a developer in JavaScript, I'm also used to not worry about memory allocation and um, just memory allocation and CPU in general, because React is doing stuff for us in a lot of ways. So yeah, JavaScript is great. It's just one of the best languages out there. But with Rust, I really want to understand how fast is it with vectors. So one of the most commonly used data structure in any programming language is array or vector. So in JavaScript, it's created as just brackets, right? And in Rust, it's you just create a vector thing, and when you need to, you just push stuff to it, and it just works magically. You get your test array with specific length of amount of a specific amount of elements that you pushed in there. That's common stuff. So these two applications are doing pretty much the same job. Uh, Objectively or subjectively, that's, well, for you to decide. So I'm trying to insert a hello world string into an array 1,000 times in JavaScript. So let's run it. So we get, well, less than a millisecond. That's fine for JavaScript. Same thing for Rust. We add a string from a static string in array, and so it's run even. Is it faster? It should be faster. I never checked. So it's in milliseconds. It seems like it's even slower. What? No, I didn't expect that. Oh shit. Alright, so it's slower for some reason. Maybe it's because it's allocating strings. Well, that's fine. See, immediately we get some weird stuff here, but yeah, that's the truth about our life. There are things that are optimized underneath, and there are things that are running faster just because they are on the machine level. But this is not the thing I wanted to check. But let's let's actually talk about the reason why it might be slower. So in Rust and C++ and all those other languages, when you add another element to a vector, I guess it needs to reallocate the entire the entire array that you had and copy it to a new array so that you got a normal array that you can access, like where you can access the items with a specific index, right? So every time when we push an element, I guess it's creating a new array underneath with all the items you had previously, and yeah, it's giving you the same array variable, but underneath there's a completely new structure with references maybe to items you added. So seems reasonable. So the thing I wanted to experiment with is actually Rust's possibility to pre-allocate pre-allocate vector size. So technically there could be a possibility to preserve some memory up front and not let your vector reallocate its length and size every time we push anything. So see, it's saying that allocating stuff at once might be, well, maybe slower. So today I read in documentation that it's possibly better to pre-allocate memory up front. Where is it? Capacity. So there's a bunch of things. Then let's maybe go ahead and just copy stuff over. So vector with capacity 10. So I'm gonna copy this structure into whatever I had in my code. So I'm gonna create a vector here with the stuff that I copied and delete that. So what I'm trying to do is actually understand if this could be lower when we pre-allocate the size. So this moment the size we want is 1000. So let's go ahead and try adding a few zeros here. Alrighty. Will it work? Alright, so it did work just slightly faster. Well, a thing to be proven, right? So we saved what, less than 100 of uh, microseconds. Um, let's actually undo that. Okay, and see maybe if we can work with 10,000 like this and see how fast it works. 3 milliseconds. All right. 3 milliseconds, is it consistent? 6 milliseconds, 4 milliseconds. Well, there's a lot of stuff that computer is doing right now, like showing my face. Yeah, let's maybe re-add the allocation thing. Whoop. Where is that? Bam. So this is interesting, just messing with just a memory allocation and seeing if we can make it better or worse. Alright, so there I have 4 zeros, is it? 1, 2, 3, 4. 1, 2, 3, 4. 4 zeros. Alrighty. And let's hope it's less than 4 milliseconds. Well, it's almost the same. Maybe this amount of elements is just not too much. So there you have it. Maybe on bigger scale with different data structures, this would be faster. Who knows? But it does seem faster just slightly, because previously, before that, it was like jumping to 6 milliseconds. Okay, let's check if this is consistent. Yeah, it's almost consistent, so it's not jumping as high as previously. So I guess this is not a benchmark, but it's still, we get some milliseconds, which is nice. If we were doing similar operation on the backend, right, we might win extra 3 milliseconds, and it would not be garbage collected afterwards like JavaScript, so we might gain actual real speed. So let's see how this thing is actually working currently. So 1, 2, 3, 4, 4 zeros. I love this comparison. I mean, readability against raw speed. It still is less. So you see, I guess JavaScript is doing something more underneath to make this code a bit faster. Who knew? Well, as a devil's advocate, maybe the data structure behind string is just more complicated. Um, let's just add a 1 in here. Okay, so it's gonna be an array of just in I32. Alright, how fast does it work? It works. Okay, see, there are spontaneous jumps in JavaScript, which is the cause of people worrying about the speed in there. So apparently the speed is not as consistent. It jumps like either twice as fast or not. So let's do the same thing for this. I'm gonna delete the string and make it I32. Capacity is the same, and we're gonna push. Oh, come on. Okay, delete that. And we're gonna push a 1 in there. So it's still a vector I32. Nice. Bam. So it takes less time to see. With simpler data structures, it's way faster. So maybe my implementation of string was not correct, which is interesting to see. Is this speed consistent? 192, 194, 2. So it jumps slightly, but we are still underneath a millisecond, like way less than a millisecond. I guess this number is the same as this one. It's just you add a point here, 0.259. So yeah, this measurement is tricky. Let's check it against again with online converter thing. Um, Bam. Yeah. So I guess we can count this micro symbol. Alright, we just consider this as a fraction of a number. Okay, cool. So we got our reference point. So this is 0.259 259, and this is 1.393. So yeah, occasionally it works almost at the same speed as you see, but still like almost always twice as slow. Sometimes 3 times as slow, sometimes even more. Nice. But to be fair, again, Rust's implementation also is kind of jumping. It's either 0.227 milliseconds or 0. Almost it's almost always 0.2 milliseconds, which is nice. So now is the thing that I started with. Maybe it's a good idea to remove this pre-allocation. So let's just remove all that. Delete. What was the syntax for this? Vec bang, like this, I guess. I don't remember. So without pre-allocation of stuff, it still runs at this speed, which is almost the same. Let's see if it's consistent. I can see a bit higher numbers than previously. It's going over 0.2 milliseconds more frequently than previously. So it does take, so previously when we had pre-allocation, it would not go over 0.25 as frequently as now. Again, this measurement stuff we have right now, the benchmark we're doing is really pointing like into the sky, like it means nothing almost. But as you see, it's almost always is 0.259, 0.2, like 0.200 something, which is interesting. Again, we do gain some speed with simpler data structures. Strings, like heap allocated strings, are slower. So maybe if I had like slices, if I had string slices, it would work at the same speed as JavaScript. I don't know, and I don't have time to check now. So I re-added the pre-allocation with the same amounts of capacity, like 1, 2, 3, 4, 2, 3, 4 numbers. Okay, let's check 0.22, and it drops even. So with pre-allocation, it can drop by not significant fraction, but it's not going over 0.3. As a matter of fact, it never goes like more than 0.3. Oh, it does. Maybe on a bigger scale, but it's not as frequent. I don't know. So again, another waste of time, maybe? I'm just wondering. If I pre-allocate this length, if I pre-allocate lengths and don't push anything and just assign a number by index, will it be actually faster? All right, yeah, I guess this is the last test I'm gonna do. What was the thing? Not const tst I think it was possible to do it like this, and the length would be 0, so 4 zeros, and I guess I can delete the previous word and this, and by index here I would set a 1. It should be the same, like functionality wise I pre-allocate the lengths, so functionality wise it's the same, it's just not reallocating uh, array lengths, and maybe not copying stuff over. It's consistently faster. So I made allocation appear before I started counting time, so it's not maybe valid. So let's do it like this. So now the new allocation is happening right before, like right after we measured time. Did I save? It is consistently faster with pre-allocated array here. All right, this is freaking me out. All right, maybe let's fill the vector with some other like initial data, and then we would go over in the same loop and just not allocate, assign a value to it. Oh boy, where was this with capacity? Oh yeah, with capacity. The range as well. In session number 2, we figured out that in small cases like this, it's fine to create range. If you go over several thousands, then it's kind of slow. Lengths. Oh, so you have to. Oh, so it's already doing that. So the capacity. Yeah. So if you read it, vector will be able to hold exactly capacity with elements without reallocating, which is what I was mentioning in the start. It's important to note that although the returned vector has a capacity specified, the vector will still have a 0 length. So we already utilized the fastest approach already. I don't believe it. How do I initialize? I want to fucking initialize. With capacity, maybe fill. See, this is not even fun. See, we are just messing with the language, so we can resize and allocate. Okay, cool. So we can resize and insert something that we want. Yes, this is what we want. This is what we want. So maybe my thing was not fair with this also. Let's just delete that and paste it in here. So our TST, yep. So I'm gonna yank. Come on. So I'm gonna resize to. Come on, press the correct buttons. So 1, 2, 3, 4, and we want to have in there zeros initially. I'm doing this just so that you shouldn't, so that you wouldn't do it, okay? This is boring. We're being nerds right now. So right after we resize it, we are able to not push but assign. I want to see if just assigning is faster, like we did in JavaScript. We generated array with a length, so it's full of undefineds, probably like 10,000 elements of undefined elements, and in the for loop we just fill it with 1. It's a stupid case, but it could happen with some other data. So I'm trying to do the same shitty code in here with index n. I will try and type in this. So our array is already mutable. If it fails, I'm just gonna stop. Oh, it ran. Cool. It's not faster. Yeah, then maybe stop. Yeah, let's stop. Makes no freaking sense anymore. Cool. Don't reallocate way too much. Done. Thank you.